Hi everyone, welcome back to a video lecture in material science and engineering, and this is the topic on heat treatment process for the steel part 2. The heat treatment process in the steel is a very large topic. Hence I have divided whole heat treatment process in two parts. Part 1 is completed. It is given in 4 different videos, and part 2 is given in maybe 2 or 3 different videos. So this is Sachin Kumar, PhD student in from the Department of Material Science and Engineering, IIT Kanpur, working under the supervision of Dr. Kaustubh Kulkarni. My PhD topic is nickel based alloy, ternary alloy, diffusion in nickel based ternary alloy. So today's topic overview is, part 2 includes these many topics. These are the different type of heat treatment process, that is spheroidization, normalization, hardening, tempering process, Oz tempering and Mar tempering. So we will see the microstructural changes, first of all, and changes in mechanical property, and its application. Finally, first of all, first actually I have to write here. So how to carry out this whole heat treatment process or steps involved. This is a complete overview of heat treatment process in steel part 2. Okay, first we have jump into the spheroidization heat treatment process. So this spheroidization heat treatment process, which results in a structure consisting of globular or the spheroid carbons in a matrix of ferrite. The final microstructure looks like globules of carbides in a alpha ferrite. This is carbides. As we know that due to this, in the globular form, a spheroid form, the forces that been applied on this material is uniform throughout the material. That's why it has more different mechanical properties or improved mechanical properties as compared to that of the other microstructures. This degree of spheroidization depends on the heat treatment as well as the folding time, heat treatment temperature and folding time. The whole process can be completed with a short period of time by increasing the heating temperature. However, the selection of that temperature is also a very important role. It plays a very important role. If we increases the temperature more and more, then the dissolved carbide particles during this process appears as in the form of a lamella during cooling. Hence, Temperature selection is also plays a very important role in the spheroidization. Important role. And this spheroidization process, heat treatment can be done in a different methods. I have mentioned two different methods in this slides. First, heat the sample, heat the steel to a temperature just below the lower critical temperature and hold it for at this temperature for certain prolonged duration of time, and then by slow cooling. This will result in the form of globular structure. The carbonates will dissolve because we are taking the long duration of time. And second method is a isothermal annealing. From a isothermal annealing, we can get the globular structure. So, as I mentioned in the previous video lecture series, the isothermal can be given as like this. Okay, so isothermal heat treatment is heating the sample above the A3 and holding it for a longer duration of time, and then it is cooling just below the A1 temperature, A3 and A1, just below the A1, and hold it for some duration, and then it is cooling. This is called isothermal annealing. From this is also we can get the globular form or sporadic form. And next is for a hyper eutectoid steel, we are heating the sample just above the lower critical temperature. This extent of lower critical temperature or extent of heating is depends upon the chemical composition of the sample. For a eutectoid steels are heated above the at about 20 to 30 degrees Celsius above the lower critical temperature, whereas hypereutectoid steels are heated 20 to 30 degrees Celsius above the lower critical temperature. In this temperature, mainly this 20 to 30 depends upon the chemical compositions. Chemical composition. Okay, so the high carbon steel and the alloy steels are frequently undergoes this spheroidization in order to improve its machinability as well as ductility property, whereas low carbon steels are not undergone a spheroidization heat treatment process because already the low carbon steels are more ductile and the are having can be easily machinable. That's why they can't be able to undergo the spheroidization process. So next is normalization heat treatment. So this is like another important and frequently asked heat treatment process. So in most of the interviews, this normalization heat treatment is asked after the annealing heat treatment process. There is a lot of similarities between the normalizing as well as an annealing, and there is a competition is also there. Okay, so let's start how it been processed. The heat in this process, the heating the steels at about 40 to 50 degrees Celsius above the upper critical temperature and holding it for the proper duration of time, and the cooling, this cooling is different from that of the annealing. This cooling is in a still air or agitated air, whereas in the annealing we are doing furnace cooling, that means slow cooling we are doing to get the equilibrium structures. Whereas after normalizing we are getting a a microstructure as perlitic structure. This is a perfect perlite, we will get it here. The temperature involved more more than the annealing. Hence the homogeneity of asteroid increases and still it results in the better dispersion of the ferrite and the cementite in the final microstructure. So temperature that we are carrying out is about more than compared to that of the annealing process, full annealing process. That's why we'll get a better paralytic region here. Whereas there is one more changes, there is a refinement of the grains will also takes place, which is most important objective of the normalizing process. Refinement of the grain size is a observable changes in the normalization. The sample which are rolled or forged will have the coarser grain size due to its high temperature involvement, and these are subjected to normalizing process to get the refined grains. It will enhances its mechanical property, ductility property. So this is normalizing process are also used as a post heat treatment process after the homogenization. Post heat treatment process after homogenization. So this can be used as post heat treatment or the pre-heat treatment process for the most of the heat treatment process, so that it can improve its final microstructure as well as the indirectly it will increases the mechanical properties and its application also can enhanced with this normalization heat treatment. So next is most debatable and most important asking question in the most of the interviews as well as competitive exams. What is the difference between normalizing as well as annealing? In annealing also we are getting paralytic structure, and in normalizing also we are getting paralytic structure. So why we have to do annealing? Why we have to do normalizing? The metal is heated and left it for the same furnaces for the cooling. This is the annealing process. Whereas in the normalizing process, metal is heated and held it for the same duration of same temperature for some time and is allowed for the cool down in a freshly air in an open atmosphere. Annealing is done before the machining process. Normalizing can be done after the forging or the rolling treatment to enhance its ductility or to get the refined grain size in the sample. Tensile strength is reduced after the annealing, whereas tensile strength is enhanced during the normalizing. Grain size changes to the large in the internal structures. Grain size is changed to very small in the internal structures. Whereas here this diagram will indicate the temperature variations of full annealing as well as the normalizing. For hyperelectric steel, this is for hypoelectric steel. Steel, it is heated above the both full annealing as well as the normalizing can are heated above the A3 time line. Whereas for the hyperelectric steel, it is different. Hyperelectric steel, this is eutectoid steel. This is for normalizing, it is heated above the A3 temperature because we are not doing slow cooling. If we are doing slow cooling, there may be a chances of getting the network like cemented structure, but we are doing a fast cooling. There is no formation of the cemented here. There is, instead of that one, we are not allowing to diffuse it properly. We are not giving a time to diffuse it. We are doing air cooling, hence it will form, the austenites are directly formed into paralytic structure. Whereas full annealing and the hardening treatment both are heated just above the A1 temperature, upper critical temperature. This is a basic differences in the normalizing treatment and as well as the annealing treatment. So normalizing steels are generally stronger and harder than that of the full annealed steel, and correspondingly the machinability of a steel shows a improvement on the normalizing heat treatment, and the steels are soft in annealed condition and they will sticks during the machining process. So we can't do the machining process for the full annealing, whereas we can do the easily machining for the normalizing because they are harder. So normalizing is very effective process to eliminate the carbide structures, network like carbide structures. Such a network is a quite stable and not eliminated by the annealing heat treatment process, since there is a representation during the cooling. Due to the short time available during the cooling, this network like does not appear during the normalizing process. This is a basic difference between and advantages over the full annealing heat treatment process by the normalizing heat treatment. Okay, this is all about spheroidization heat treatment and normalizing heat treatment process. So next remaining heat treatment we will see in the upcoming video lecture. Thank you.